assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So here we can say that they pass each other at time t, where we say that x sub 1 is equal to x sub 2, and this is equaling 1/2 times the maximum displacement. So we can say x sub 1 is equaling the maximum displacement times cosine of omega t plus phi sub 1. And then we can say x sub 2 is equaling the maximum displacement times cosine of omega t plus phi sub 2. So here we can conclude here that cosine of omega t plus phi sub 1 is going to be equal to cosine of omega t plus phi sub 2, and this is going to be equal to 1/2. And so we can then conclude that the phases are either both equal to pi over 3, or one is equal to pi over 3 while the other is equaling to negative pi over 3. So essentially, we have that. We also have that v sub 1 is equaling negative v sub 2, and this is not equal to 0. So essentially, we can say that, let's get a new workbook. V sub 1 is going to be equal to negative x sub m, the maximum displacement, times omega times sine of omega t plus phi sub 1. V sub 2 would be equal to negative x sub m times omega times sine of omega t plus phi sub 2. Now, this leads to sine of omega t plus phi sub 1 equaling negative sine of omega t plus phi sub 2. So here, this leads us to conclude that the phases do have an opposite sign. So we can say one phase is pi over 3, and the other phase is equaling negative pi over 3. So essentially, we can say that the omega t term cancels if we take the phase difference. So we can see that the phase difference we can say that this is going to be pi over 3 minus negative pi over 3. So of course, 2 pi over 3. This would be our final answer for the difference in the phase. That is the end of the solution. Thank you.